Welcome back to Database Fundamentals. This is Module 4. We're up to Module 4.
I know, definitely.
Yeah, it's gone by really quickly.
It is.
Yeah, but it's been fun. We started out with kind of the very conceptual Module 1, where we looked at some of the core concepts to creating a database, or to databases and why we needed them. We started with our big spreadsheet. In Module 2, we talked about relational concepts like normalization and referential integrity. And we just got out of the Module 3, where we learned how to actually create databases and create tables. And that was something that we called DDL, Data Definition Language.
Nice, yeah, exactly.
And now here we are in Module 4, which is, it even has DML in the title, which is Data Manipulation Language.
Correct.
Is that right? Manipulation Language?
Yep.
I always
Sounds
get
good to me.
confused about these acronyms, DML and DDL and DCL, which we're going to look at later. But in this module, we're going to actually take a look at finally using data. We're going to take a look at, we're going to start, I think, with how you actually use the select statement, which is kind of the bread and butter of querying a database. And then we're going to talk about some of the other DML statements for doing inserts. We'll actually look at how we got the data into the database in the first place and how to do updates and deletes as well. But take it away. I can't wait. This is probably the big module for the course, and I know that you've got all sorts of cool demos for us.
Yeah, the cool thing about this is we talked about the importance of data types and being able, like we've been saying, the Excel spreadsheet was nice if you had just a few rows. You weren't worried about slicing and dicing your data. But if you get it into these tables inside the database and with these relationships defined, this is where you can really, the magic happens by being able to use the select statement. It's that simple. It's really using a DML select statement. So we're going to talk about that here. Specifically, we're going to start talking about the select, and then we're going to talk insert, update, and delete real briefly there. Let's skip a few slides at you. So select statement, here we go here. With this, it's used to retrieve rows and columns from a table. I showed you the most basic select statement there is. Select asterisk, which means all columns, from, and whatever table name. That's as easy as it gets. So with that said, though, you may not want all columns. You may want specific columns. That's what we're going to do. Is we're going to introduce different ways for us to really start slicing and dicing the information. Because right now, if I do a select asterisk from a table name, to me, I'm doing what I call a table dump. I'm just dumping every row and every column, and so I might as well have a spreadsheet. It's not quite that bad, but what this does now, I've got choices. I can choose what columns I want to display, and I can choose what rows I want to display. Columns are chosen by, instead of doing a select asterisk, you specify the column names. Instead of not supplying a where clause, you supply a where clause, and that introduces what the criteria is on those rows that has to be met for those rows. So now you're narrowing your results down both in width and in height, because now we're getting only certain columns and only certain rows because of what we supplied. This is an example of it's still a fairly simple select statement, but now we've taken it down and we've supplied 3 column names instead of the asterisk. And instead of dumping everything out from the employee table, we said where business entity ID is less than or equal 50. So we're actually supplying a where clause that's saying I want to see everything from 1 to 50. Where business entity is 1 to 50. And this is what I want to see. I want to see job title, and I want to see gender. So that's what we're doing. We're specifying the actual columns, and we're specifying the rows. The rows are driven by the where clause. The columns are specified right after the select clause as to what columns that you want to see. So this is taken from a simple select statement to, now I'm getting a little bit more picky about what I want returned to me. I can get pickier. I can add multiple criteria to the where clause. So notice here now, I'm still doing a select on these 3 options: business entity ID, job title, and vacation hours now. From the table, still have that. Now my where clause, where job title equal designer engineer, and oh, by the way, gender has to equal F, and oh, by the way, their hire date has to be greater than or equal to January 1st of 2000. So now I'm really narrowing down what's returned to me in my result set. I'm specifying 3 bits of criteria. They all have to, each record that's going to be returned has to meet. They have to be a design engineer, they have to be gender female, and they have to have been hired later than January 1st of 2000. So I'm getting very specific. Can you do that in Excel?
I can. I was actually just thinking.
I can't. I'm no Excel guru, but I'm pretty sure you can't even do this.
No, and what's awesome is that right away here in Module 4, you've solved the thing that I was wondering about all the way back with my spreadsheet, which is how am I going to figure out how many jazz albums I have,
Exactly. Yeah.
right? Or
Right.
which are the jazz albums in my collection? And you just showed me with this criteria, this where clause
Right.
on the select statement with all the referential integrity that we've got. I just need to reference where genre equals jazz, and I'm going to get just those jazz records out of my
Right.
out
Or
of
your
my
disco.
albums
I know
list.
you keep talking jazz, but I still think you got
It's a very small
got a
list
slew
of
of
disco
discos.
records.
I
Don't
think
knock
you do.
disco
No,
as an
I think it's
important
good
genre.
stuff. There's a lot. There's a good time for that. So the next one, instead of using an and clause, we're using an or clause here.
Yeah.
Select business identity, entity, job title, vacation hours from the same table, where vacation hours is greater than 80, or, so it could be anybody has more than 80 hours available to them, or their business entity ID is less than 50. So pretty much I'm going to get everybody 1 through 50. And then anybody else that has more vacation hours than 80 hours are also going to be displayed. So now I've increased the number of rows in comparison to the other one. So my and clause is it has to meet all 3 criteria. My or says it's going to meet either of these criteria, and I'll get that returned to me. Okay. By the way, I'm going to demo all these for you. We're just going to walk through them so you understand what they're all about, but we'll see these all in action in just a little bit. The between clause, instead of specifying the ands, or if I want to specify between a certain date range or between a certain, in this case here, vacation hours, very, very similar syntax. Select the column names from the employee table where vacation hours is between 75 and 100. Now I could have done this a different. I could have said where vacation hours is greater than or equal to 75 and vacation hours is less than and equal to 100. That would have worked, but this is a between. This makes it a little bit simpler. So now I'm going to say if the vacation hours are between 75 and 100, I want to see those rows. So it's just another way for us to massage or slice and dice the data as it's being displayed. Now the bad thing is right now is we're getting data dumped out to us, but we might want some sort of order to it. What we're going to do now is sort the result set using the order by clause. So what we're going to do is we're going to take the same content with the same command we had in a previous slide, select business ID, job title, and vacation hours from employees, where vacation hours between 75 and 100, and order the vacation hours, order the content that's displayed to me by vacation hours. So the default is ascending. So anybody who has 75 hours is going to show up first on the list, 76, 77, all the way down to 100. So I'm going to actually specify how I want that content returned to me. You can reverse that. I used the same exact command on the bottom of the slide here. And on the reverse of it, all I did is I added this DESC, short for descending. So now instead of seeing 75 at the top of the display down to 100, I'm going to flip that and see 100 down to 75. So it gives me an opportunity to sort and decide what order I want to sort them. And it doesn't have to be vacation hours. It could be by date. It could be by alphabetically. We can choose what column that we want to order that by. So now we're getting some order, no pun intended, to how the content's displayed to me. It's not just dumping the data out because it met the criteria. We're telling it how we want to see that data displayed to us using this order by clause. So it gives us a little bit more control of how that content is displayed. So that's saying how we want to grab content. What if there's content we don't want to see? We've got the not clause. So what this is, I'm going to grab this 3 items, business entity ID, job title, and gender for columns, from the employee table, where not gender equal M. It's kind of weird when you say it, where not gender, but where not gender equal M. So when I run that, I should only see gender equal F, because I don't want to see, I'm telling it, I don't want to see gender equal M's, I just want to see items where. Now I could have expanded on this. I could have said where not gender equal M and title equal design engineer, or something like that. So again, I can expand on some of these commands more so than what we're showing here. I'm just showing you different flavors and the power of relational tables in a database that we didn't have in our spreadsheet, because now we have control over what data we want to see, how we want to see it, what data we don't want to see, and I really want to be more restrictive on. I want my disco CDs that's got Celebrate on it or something like that from a certain artist. Do you have that one? I'm just curious. It was just curious.
You're bound and determined to get me to disclose which disco albums are in my collection.
Yeah, no, we'll find out. We got a little time. Okay, the union clause. What if I have content that's in 2 different tables? Yeah, we can do that. So right now what we've been looking at is all right, you're telling me I can grab content from a table. What about if I have content from 2 tables? Well, this is what I can do here. as long as the columns are matched. So as it says up here, it allows you to combine the rows, return from multiple select statements into a single result set. So we're doing select business entity ID, job title, and hire date. We're selecting that from the employee table, where we're still supplying a job title, where clause, where job title equal design engineer. Now we want to union that. I don't want to use the word merge because there's an actual statement merge. We're going to take that content and we're going to have content from the second select statement. Again, the columns have to match business entity ID, job title, hire date, from the employee table, where hire date between 2005, January 1st and 2005 and December 31st of 31. December 31st, 2005. These dates are weird for me. I'm not used to having the year first. So now we're going to union. We're going to take two select statements. We're going to populate the content into one result set, but there's actually criteria from two different statements. And we're going to return the same column. So we'll see how we can have a statement that returns columns based on pretty much two separate where clauses and two separate select statements. This could be a different table. If I could go out and do select business entity ID, job title, hire date from human resources dot X employees, if I wanted to, where hire date or fire date was a certain date. You can do that as well. As long as the columns match up, you can retrieve that content from different tables here. So this is the union clause, and again, we'll see how that operates for us here. The accept and the intersect clause. So the accept clause returns distinct values. Distinct means unique in the sense that I don't want any repetitive data. So now I'm saying, okay, so if I did a search, I want to do a search of my CDs where genre equals disco, and I've got the same artist. I may not want to see the same artist. I want to see all my disco albums, and I think that's probably 100-ish that you have.
It's at least 100.
It's at least 100. So anyway, but I don't want to see the same artist each time. So I want distinct. I want unique artists that with the genre of disco. So what I do is select product ID from the product table, except, and then select product ID from production.work order. So it's going to return both of them for me. All right, but anything that's matched, it's not going to return that. So it's not going to return anything. That's a match. It's going to just do the distinct items. The intersect clause down here returns any distinct values returned by both the query on the left and on the right. So what this one's going to do, the left being the first query, by the way, they term it as left and right. It's the first query. It's left of the intersect statement. Let's put it that way. So this is going to say returned. So the first one up top, let me go back there. From the left query that are not found in the right query. So the accept is return distinct values from the products table that are not found in the work order table. This one down here says return by both the individual information, distinct values again, not everything, but distinct, by both information that's distinct in the left and the right sides of the intersect operand. So anything that's distinct in product and work order will show up in that second one. All right. And again, I'll show you a result set of that as well. But it's just ways for me to be able to slice and dice that content that we just were impossible to do with 1,000 or so rows in a spreadsheet. But by being able to create relational tables inside a database, we're able to manage that data much easier. The join clause is it's a little bit more advanced. We're just going to introduce the concept of a join here. There's a few different flavors of joins, but it allows me to use content from two different tables. So an inner join uses a comparison operator to match rows from two tables based on a value that exists in both tables. So product ID, we'll go to product ID. I could go to do a join, a product ID from one table, and do a search or select on a product ID from another table. And with an inner join, it's going to look for matches on that product ID and give me that content. Okay, so it's a match. Outer joins, if it's a left outer join versus a right versus a full, but if it's a left outer join, it's going to include rows from one or both tables, even if they don't have matching values. So if it's a left outer join, it's going to give me everything in that first table. All right, we'll say it's the product from the products table, and then any match from that second table. So that's what it'll do for that. So if it was a right outer join, it'd be everything from the right table and only the matches from the left table. Cross joins is also, I think this is also, no, the cross join is going to return all rows from the left table and all rows from the right table. So it's pretty much a table dump for both of them, unless you supply a where clause. If you supply a where clause, then it'll narrow down what's being returned. Otherwise, give me everything from the left table, give me everything from the right table. It's kind of a good way to generate a bunch of content into a temporary table, and you can use that for testing content or testing other statements that you want, because you want to generate 30, 40,000 rows of content. So joins allow you to combine related data from multiple tables, and we're going to kind of leave it at that. It's more of an advanced topic, but just want to let you know, because we're creating multiple tables, doesn't mean I can't grab data from multiple tables. I can certainly do that, and do that using one of these different types of joins that we can look at, and you can maybe experiment with.
This seems like it's a great opportunity to plug another Microsoft Virtual Academy session that you're doing. We're actually recording it tomorrow. That's a whole session about the T-SQL querying language that you're doing with Tobias Turnstrom.
Yes.
That's going to go really deep into these topics. So keep your eye out for more content on Microsoft Virtual Academy if you want to go deep on the querying.
Yeah, so some of these that we're just doing the high-level approach on the fundamentals. This is querying SQL Server, querying Microsoft SQL Server 2012. That's going to be recorded. It'll be out shortly on Virtual Academy, and you'll be able to review that with Tobias and I. So great point. Thanks for bringing that up and reminding me of that.
Because you kind of blew my mind with joins are complicated on their own, and then you went into inner joins and outer joins, and it gets super complicated. For the purpose of my CD library, it's way out of scope.
Yeah.
But I can see where I'm going to want to go get more information about that when I start like hooking up to the Xbox Live Music service and figuring out which music I have that's also on the streaming service, things like that. Once I get really into my application that I'm going to build.
Yeah. I'm waiting for
Monday.
I'm going to be your tester on that.
That's right.
You'll send me an SQL. Run this. This is an example of what are called aggregates. And so what we've done here is I don't want all the tables. I need some average information. I need some information that's aggregated. So what this does is provides you summary of data. So this example does a select count distinct sales order as unique orders. So what this as does is just gives it a different column header. Just want to throw that ID in there for you. So select count, so it's just going to do a count of all distinct sales order ID. So if I got a sales order ID of 1, 2, 3, it's only going to count, and I got 10 line items in that, it's only going to count it once. That's that unique sales order ID. Then, by the way, for that sales order, I want the average unit price. Not for that sales order. In addition to that sales order, the sales orders, I want an average unit price. I want to know the minimum order quantity that was ordered in any of the items in that sales order detail table. And I want to know the max line total. So what's the maximum amount one item or one line item was charged? What was the maximum amount, what sale on one line item? So this is taking content, instead of dumping all the detail out, it's actually providing you a summarization of this content and showing you how this content would be displayed and what your min or what your max and what your average was and what the total number of records are for a particular sales order ID. So again, I will demonstrate that for you so you have an idea as to what that looks like. Those are really, really powerful. For instance, Pete may want to go in and say, well, how many disco CDs do I have, or albums? I'm trying to call them albums. He could go in, he could do a count where he could do select, count, distinct, from the genre, that'd be where it would be, and where name equal disco. And so it would give him a total number of items. No, actually, we wouldn't do it in that table. We'd have to do it in actually the album table.
Do it in albums.
Albums table,
select the distinct count.
Yeah. And then we give him all the disco albums. So then we truly know how many disco albums he
disco.
has. Definitely. Because he doesn't want to tell us. But we'll see that one in action just a little bit here. How about right now, in fact?
I'm pretty sure for Christmas you're going to get me the complete works of Donna Summer anyway, and then the whole
Well,
count.
I wasn't sure what I was going to do now, but I don't know. Disco Gone Wild.
I might already have that.
Oh. Well, let me know so I don't buy it again for you, because I'd hate to do that. Okay, let's go back into Management Studio here. SSMS, I'm over on my desktop here. I'm going to open up another query item, query file.
All the students really wish that you had my CD library data for all of these samples.
Yeah. All of them are going to go find out, like, who did celebrate?
Sadly, I think we're going to use Adventureworks now, aren't we? Is that where the demo?
We're still, I'm sorry, we're staying with Adventureworks.
We're going to stick with Adventureworks. So can you just give me a quick overview one more time for the people who are just joining us?
Yes.
Adventureworks tell me about the data, because I think the samples we've been using make a lot of sense, because it's pretty easy to wrap your head around a music library or around a grocery store. But what's Adventureworks and what kind of data is in there before we get too deep into these samples?
That's great. Great. So Adventureworks is a sample database that's provided that you can download, install if you want to test this in your SQL Server world, and it provides us sample data. And as you can see here, I'm just going to open up the tables. It's got human resources, got employee, department. So they've already done the normalization. They've already done all the relationships for you. It's got an entire area, 2, 4, 6, just in human resources, a dozen or so on person. Notice they have a person address that's separate than address type. They have a contact type. They have a password. They have a person, and then they have person phones. Then they have the person phone type. I mean, they've really normalized this data to the nth degree. And then the production, all this information about production category or product category, product photo, product photo, not quite sure what that would be, product reviews, scrap reasons they got rid of content or a product. And then we've got purchasing information. All right, we've got product vendor, vendor order detail, vendor order header. I mean, it's just all been totally normalized, and there's, as you can see, dozens and dozens of tables in here.
It's interesting because Adventureworks is a huge enterprise database, and the hypothetical company Adventureworks sells sort of adventure products, but they have data in their database that manage the business of running Adventureworks, so all the people and HR stuff.
Yeah.
But it's also got the product catalog and things like
Purchasing,
that.
sales.
And all of the sales, and it's all in that one database, which is how they chose to do the structure. And we can say that Adventureworks is a little bit contrived so that it makes a really concise sample that people can use.
Right.
But there's lots and lots of data in there, split up into a variety of different sort of business data that we're going to use in the sample.
And so we had just had someone chat into us and say that the longest album title ever is 89 words long. Words. I thought it would be characters.
89 words. We would need a full character
find that.
count.
Yeah, I have to. I mean, I would know. We have to figure out the character count.
Average length of the words. I don't think we have enough information really.
Yeah, not enough to make a decision on how we create that field. But it's information like that. You'd be surprised. The 89 words, I would have never guessed that, without a doubt.
So if the Adventureworks product catalog had album titles in it, then the product name field would need a data type to accommodate an 89-word name.
Yes, exactly.
Got
so
it.
it's stuff like that you have to think about while you're actually designing your database, because I would have never guessed that. I'd have probably gone 50, 60 characters, 100 max. I'd have gone 100 max for that, just off the cuff. And now I'm thinking, that's not anywhere near enough. So, well, thanks for chatting that in. That was great information. So now, if you could find out who did Celebrates, because Pete won't tell us, that'd be awesome. Cool in the Gang. Wow, that was quick. That one came in. Somebody's got that in their collection. Okay. All right. Adventureworks. Module 4. We're back in Adventureworks. Thanks for reminding us to kind of just show what it looks like in case someone joined us here a little bit later on. We talked about this table dump. Remember, this is pretty straightforward. We do a select asterisk, and again, this is all scripted, so I can just not cut and paste. I can highlight. Actually, notice up here I'm in the wrong interface or database. So I'm going to grab Use Adventureworks. Remember, I try to get in the habit of just using or supplying the Use Adventureworks only so I know that I'm always in the right database. You saw a couple times doing a demo, it didn't work. It's like, oh, wrong database. So if you can include that in most of your statements, especially if you're bebopping between a couple different databases, it'll be helpful for you. So let's do our basic statement. We're going to go ahead and execute this baby. And you're going to see we got pretty much a table dump. We got business entity, national ID, and I'll scroll over here. Trying to get you dizzy, I'll scroll slower. And this is pretty much everything there. Notice there's 290 rows. If you can see way down the bottom, there's 290 rows that were retrieved from that table called employee. All right? And you can see, you saw all the columns as I scrolled from the left to the right, and I'm going to scroll back. So we just pretty much did a data dump. Now again, you've seen all these slides. So all these slides are, now we're going to show you how these slides that contain the text on the statements on there. Now we're going to show you how they work. So then we went from the table dump to say, now let's decide what columns we want and how we're going to throw a where clause in there. So we're going to execute that one now. So now we're going to see business entity ID of equal 50 or less and 3 columns instead of all of these columns. So we'll execute this one. Here's our business entity ID, here's our job title, and here's our gender. Now if we scroll down, we should see business entity ID 1 through 50. And I just hit bottom, and you'll see over here, whoops, 50 rows. And we just got important information into us, 360 characters for that 89-word title. So we would have to have a varchar, because that's going to be huge compared to everything else, of 360 characters. I mean, who'd have thunk? I'd have been 100 max.
I had no idea.
Yeah, and celebrate that. All right, so that's cool. Now we've narrowed down the rows and the columns. Let's go in here with our multiple where clauses. Get this back down a little bit here. This is where we got the same. We had 2 columns here. The third one of vacation hours from the employee table now. Still, job title equal design engineer and gender equal F, and hire date is greater than January 1st, 2000. So let's see what kind of content this will return to us. And like I said, it's okay if you highlight the comment. It's just going to ignore that anyway. And you'll see we have 2 people who meets the criteria that are design engineers, have vacation hours of, what did we just say? Oh, we didn't care about that. A business entity is 5. And that was supposed to be, I could have changed this one a little bit.
Well, the where clause is showing you what you got back. We just didn't include the columns in the where clause. And that's pretty interesting as queries go.
Yeah, because...
Because we can assume, since we have and gender equals F, that everybody there has F. So we didn't really need to return it as a row in the query. Or as a column,
What we could do is,
query.
let's do what's on the fly here. Let's change this to hire date. And let's change it to
sneaky
gender.
You want to see it anyway, just to prove that your query works?
Yes. Gender. Okay, business entity ID. No, we want job title. We don't even care about this. Let's get this guy out of here. And we'll get job title. All right, let's try to run this baby again. So job title is design engineer, gender is female, and hired on 2/6 and 2/6 of 2002.
Right, and we would have kept the employee ID in there just so that we could figure out who they were, so that we could go and use that information in our application.
Exactly.
Yeah.
There we go. So we could find out who they were.
Because that's the key in the employee table.
That is. Now, how do I find out their name? This is where it would be helpful for me to now. Remember, this is going to be a primary key called business entity ID somewhere out there. And we can probably go see it real quickly. Tables. Under human resources, we're coming from employee. We'll probably maybe person.
Why don't we go look at the fields that are in the employee table to see
person. Person.person. So I would map that business entity ID.
But hang on a minute. You're jumping ahead, though. All we're doing is we're looking in the employee table. How do we know it's not there?
Oh, I thought I just showed you that. If we open that right
Let's just reiterate.
Here is the employee table.
So I want to just stress the foreign key that you're implying here.
Okay.
Right?
So here's this guy here.
There is nothing in here. There's job title, but the name of the person is not there.
Right.
So how do we get from there to person?
So we get there from there to the person. We get into one of those joins, and then that would map to, and we won't get into that, that would use that business entity ID.
The business entity ID.
That would map to this guy over here for this 5 and 15.
Got it.
And we could grab the first name and last name from there as well.
Got it.
Nice.
So it's both the primary key and has a foreign key relationship to the other table.
Yeah.
Got it.
Yeah. Cool stuff. All right, so we got creative with that one. On the fly is good, most of the time. We'll do this one now. This is that multiple where parameters with the or. So this is the and. So this is where we want vacation hours is greater than 80 or business entity ID is less than 50. So now we're just kind of deciding. I forgot one of this thinks it's a, there we go. I forgot one of the little dashes. So now we've got these folks here, business entity ID, job title, what we're looking for. Vacation hours greater than 80 or business entity ID is less than 50. So notice this one here doesn't meet the criteria of vacation hours is greater than 80, but the business entity ID is less than 50. So we still get that returned to us. Now I thought, did I do it the other way? Yeah. And here's a between. Oh yeah, that's later. So here's the between clause that we talked about. Now we want vacation hours between 75 and 100. So this met two different criteria. We got rows returned to us. This is going to say we're going to get the same content. We're going to get content returned to us where vacation hours is between 75 and 100.
So these are the people that need to go on vacation before they lose.
I don't know why I'm not listed in here.
Hours.
I should have a vacation. So notice we have 99, 80, 82, 79, 98. But there's no order. I mean, the only thing, by default, it kind of dumped it out by business entity ID. But that's just, you can't count on that. I mean, it may do it pretty consistently. But if you really want it to be displayed in a certain order, you're going to want to use the order by option. So I'm going to use that same command I just used up here, but I'm going to order it by vacation hours instead. And by default, it's going to be ascending. So I'm going to run that. See now, instead of sorting it by business entity ID, it's sorting it by 75 vacation hours, 78, 79, 86, all the way down up to 99 vacation hours. So now I'm controlling how the content's being sorted. Remember I said we could go in reverse order or descending? I'm taking the same exact command. I'm adding the DESC on the end of it for descending, and I'll execute it. Now the 99 start up at the top, and they go down to the 70s in the bottom if I scroll down. All right, so we can control that, and it tells you how many rows, by the way. If you're not quite sure, there's always down here, it tells you the number of rows. If you quickly jump over here, it tells you how many rows. So if you're curious in some of these commands, like how many rows did that affect, jump over to the messages, or if you happen to peek at it, it happens to be down on the right-hand side. It'll show you how many rows are affected. And there's some commands coming up, I think, we're going to hit thousands that might work, so it'd be good to know. All right, using the not clause. We showed you this. This is where I want to see anybody where their gender is not male from the employee table. We'll execute that. So they have 84 rows from the employee table. And then we're going to go in and we're going to do a union. This is where we can get content from two different tables or two different options. So we're going to combine data from multiple tables. It's actually the same table, but we're going to do this. We're going to get business entity, job title, and hire date, same as down here. It's two different select statements with a union in the middle. From the employee table, where job title equals a design engineer, and hire date between January 1st, 2005 and January 31st, 2005. Now, what's a way we could have done that differently? Did I really need to use a union? I could have with the where job title equal design engineer. I'm trying to do a union. Or hire date between 2005 1-1-2005, 12/31/2005. I could have done that in a single statement. Unions are probably a little bit more powerful if you go two different tables. It's difficult to find two tables that have repetitive columns in them, though. You might have a choice. You might have like an employee who happens to be a customer, so they're in there as first name, last name, maybe city. But it's sometimes difficult if you've done all the normalization to find columns that are that don't match the actual data, the values in there, but that match the columns required. In this case here, business entity ID, job title, hire date. Or let's use first name, last name, and city. I could probably find that in a couple different tables and then just join those that way as well. Here's the returning distinct values from the left query not found in the right query. And we'll execute this one. So product ID. So it searched product table and it searched a work order table. And it found 266 rows. Let me click this guy here. That had unique values in them between the two tables. All right, and I could have added more information as far as what table it came from and other information about the product, maybe description, but just to show you that we can grab. This is going to be the intersect versus the accept. This should be bigger. So we're going to highlight that. We're doing the same thing, but we swapped out accept for intersect. And we got 238 rows actually. So let's see, distinct values returned by both queries. What was this one back here? Oh, these are ones not found. So these are really just turned in from one query, and these are from both queries. You think there'd been more in that one? What was this one? Let me run this one again.
This is an example because I'm not familiar with the work order data, that when you're looking at the results, the only real way to know if it's working is if you really have a fundamental understanding of the data that's in those tables, so that you can logically deduce if you're getting results that make sense.
Yeah. Yeah,
Right.
that data modeling part you were talking about.
That's
like
right.
Understanding the data types, why they're there, what to expect from those data types. So exactly, this is the Adventureworks, unless you've studied it.
And if you're writing the query and you don't know, then you have to go find the person who owns the data that's in there to say, this is what I got, but is this what you expected or not?
What should I expect from here?
Right.
Yeah, perfect. Here's my aggregate function sample. We've got the count of distinct sales orders, unit price, order quantity, average unit price, sorry, minimum order quantity, and maximum line total. So we're going to go ahead and run that. It's all aggregate functions, so we're going to get one line. Unique orders, 31,465. Average unit price is $465 and some odd. Minimum order quantity is 1. I would hope so, otherwise it wouldn't be an order. And the maximum line total on of all the items in the sales order detail is 27,893.
So hang on, let's dig into this for 1 second. You did a select count of distinct sale orders, and you added a bunch of aggregate functions.
Right.
So basically in one T-SQL statement that is 5 lines of code, you summarize all of the sales in my system.
Yeah, try that in Excel.
That's pretty amazing.
It's really cool. I mean, I know right now that the average price, what do we have? We have, these are unique orders. Let me just do
31,000 orders.
That's unique orders. Let's take this baby out. Let's just grab every order. So let's take that and run that now. Now it's 121,000 orders.
And the average unit price of each order, of the orders.
All of the 121,370 was $465. I don't know what they're selling, but I like it. And still the max, that's not going to change. This probably changed because we have more rows in there.
Yep.
But so again, just removing distinct dropped it, was it 38,000 rows?
Something like
brought
that.
up to 120,000 rows just by removing that one clause. So that distinct clause is really, really important. I just want to show, okay, so what we're going to do now, this is inserting data. What we're going to do now is go back to PowerPoint is what we're going to do. So I don't get too demo happy again. Oh, I keep doing that. I'll let this guy come down here. All right, let's go back in. So those are select statements. So some of the stuff we just showed you would be impossible to do with Excel. And it's just all we had to do is it's the upfront work. It's the data modeling. It's setting up the relationships. Once you have that done, it's just so much easier for you to slice and dice the data. So that's the select statement. That's just a piece of the select statement that we're looking at here. So and there's more. Again, that querying SQL Server, Microsoft SQL Server 2012 class. We're going to dig much deeper in those joins and a bunch of other items tomorrow, or when we record that. All right, we need to add data. So in order to add data, we can use the insert statement. So we do an insert into, and then we supply the table name, all right, in the schema. The values, all right, so I'm going to add into, now notice I'm not supplying any columns. I'm going to just say, if I know this, if I understand the columns that are in there, I don't need to put the column names in there. So I'm going to say insert into production.unit measure. Value of the first field is going to be FT. The second field is going to be feet, and the third field is going to be a date, okay? Now, what this is going to do, and again, I'll go back out and execute this, it's going to add a row into the unit measure. Now, if I want to add 3 rows, I could go in something similar, insert into production.unit measure. Here's the first one. I thought I changed, I changed it in the script. And here's another one, so I'm adding square feet. I'm adding square, trying to change it, I can't do that. I'm going to add yards, and I'm going to add cubic yards. My script is slightly different, so when I go out and show you that, this is going to be slightly different. I changed it because I wanted to show you something. Because right now, I'm hard coding a date. That's really kind of unrealistic. What I'm going to show you in the script is, why don't I just throw in today's date? So I'm going to change, I changed this a little bit, so it's going to actually go out, retrieve the system date, and populate that instead of this hard-coded date. So that's how I can add content. Insert into either an individual row or multiple rows using insert into. If I have a flat file, just a file, a .txt file, for instance, and I want to add content from that, I can use what's called a bulk insert. And there's a specified format, specific format you need to use. But I'm just thinking, what if you have an Excel spreadsheet, you dump it out to a flat file with comma delimited, can I get that into SQL Server? You can. And the easiest ways to do that is to help SQL Server understand the format of how that data is stored in the text file, using a format file, and then using a bulk insert command. It'll take all the rows in that file, flat file, and move them into a table. That's all I want to say about that, but it's another way to add a bunch of data, or if you've exported data from somewhere else, you need to get it into SQL Server, that's going to be your choice for doing so. It'd be a lot faster, again, unless you get paid by the hour, where you want to do individual insert intos, go ahead and do it that way, but a bulk insert would be much more efficient. All right, the update statement. We're going to update salesperson. Again, I changed this query slightly to stay with our theme, what we were working with. But update, you specify the table. Set is the key word here. Set bonus equals 6,000, commission percentage equal 10, and sales quota equal no. So what this would do, it would set those values on those three fields where sales.salesperson.business entity equal 289. That's a huge problem if you don't put a where clause on an update statement. If that where clause wasn't there, what would happen just now?
Everybody would have gotten a bonus.
Everybody would have gotten a $6,000 bonus, a commission rate of 10%, and a sales quota would have been set to null. That means they don't really have to work. That to me was what I call an RPE. Anybody heard of an RPE? And I teach the admin class for SharePoint and SQL Server. An RPE is a resume producing event. We want to avoid resume producing events. I think everybody getting a $6,000 bonus, executing this command without a where clause could be an RPE. So we want to be careful with those. All right, delete statement. Delete from the table where production.unitmeasure.name equal feet. Again, if I did a delete from without a where clause, what did I just do?
Deleted everything in the table.
Wrong. I toasted everything in the table because I want to use the toast command. But yes, you're right. I deleted everything in the table. So when using updates and deletes, where clauses, is that a word? I don't know. They're essential because you can really mess up the data if you don't do that, if you don't supply a where clause. A delete statement without a where clause will cause all rows to be deleted. That's my point I'm making there. And I got slightly different commands in the query. Is there anything on this? Looks okay. Okay, so let's go take a look at this now. Let's go back into these statements here. And we're going to pick up where we left off. First off, I want you to see what we have for information in the unit measure. So I'm just going to query that, kind of do a table dump. And what I want you to notice is that we don't have anything in there for F2, got an F3, but no square foot, square feet, cubic foot, no square miles. All right, so nothing in there for miles for M3. So I just want to show you that. Now what we're going to do is we're going to insert a row of information. And I'm going to insert this one. And notice what I also do differently. Instead of hard coding the date, I'm going to insert into this unit measure FT, N feet, and then get date. It's going to populate today's date in there instead of a hard-coded date. So I'm going to execute that. One row is affected. I'll go back and query that table in just a moment. Remember, I could do multiple statements. So here's that one. FT2. So remember, FT now should be in there. FT2, M2, and Y2 are being added. Now notice I intentionally called this square foot. In case you're thinking, like, dude, don't you know how to talk? That's on purpose. And I'm going to execute that. 3 rows affected. Let's go back and query that. All right, we're going to F5 this. Now we're going to look for our FT and our FT2. Just scroll down here. Here's my FT I just added. Here's my FT2 with a square foot I added on purpose. That was wrong. Why did I do that? Because I want to show you the update statement. We're going to change. We're going to do update product.measure or production.unitMeasure. We're going to set name to square feet. Name is right here instead of foot. Where production unitMeasure.unitMeasure code equal FT2. So this dude right here should end up with square feet. So we're going to execute this guy. All right, 1 row affected. And then we're going to go back and execute this command to find out what's out there. See if we have a square feet instead of a square foot. We'll go down to FT2. And notice now it updated just that one column. Again, without this where clause, every item in here would have been square feet. So we got to be careful about that. We can delete a row. Delete from. Again, we need that where clause. We're going to delete the FT. You'll see it's right there. Simple statement, delete from the table. and then you specify the criteria. Execute that. We'll query, see if FT is gone. And you'll see that FT should be gone here. And you'll also see, so I didn't point that out to you the first time, FT is gone. You'll see now that square feet has today's date instead of that 2008 hard-coded date. It actually went out and grabbed the system date and time and populated that for us. All right, so that's the DML statements other than the select statement. That's the other items. Inserting, just a brief introduction to inserting, updating, and deleting content inside of SQL Server. We got just a couple more items that we're going to introduce. We're not going to go in depth on these, but these are indexes and triggers. I briefly mentioned the triggers already. Indexes, we talked about, we have either clustered or non-clustered index. The big thing about those is you can only have one clustered index. Indexes are very powerful. Notice the first line. Allow you to speed up the retrieval of data stored within a table or view. Okay, that's the primary reason we add an index, is to speed up the retrieval. There's a bit of overhead involved with inserting content if you have indexes turned on, especially a clustered index, because it physically sorts. If I have a clustered index on the last name, every time I add another last name in there, it's going to shuffle that data around to make sure it's alphabetized. Or if it's an ID, it fits in that ID, in that row. So they're used to speed up your retrieval of content. We'll just leave it at that. We have clustered index, we have non-clustered index. You can only have one clustered index because the data can only be stored one way physically in one order. And we have any number of several non-clustered indexes. And remember I talked about the unique index. If you're looking for uniqueness on columns, you want to enforce uniqueness. The primary keys, you can only have one per table. Your unique index would provide you that functionality. Creating a trigger. Triggers are used to enforce a business rule. And then we'll just wrap this up. I got one more quick little demo on the trigger so you know what that does. You don't think I'm just making up that word.
It's not the name of your horse.
No, Roy wouldn't let me. Was it Roy? Roy Rogers? Was that trigger?
Whose horse was trigger? Roy Rogers.
Roy Rogers. Look at how old I am, huh? Okay, so we got this content here. All this trigger is doing is called insert success. This isn't doing much except for I just wanted to show you what a trigger does. This is a DML trigger. This is saying whenever anything gets inserted into the unit measure, it's called raise an error, even though it's not an error. That's just the term they use. It's called raise an error, and it's just saying, I just want to get a quick little message saying this was added. Remember, this could be something like, hey, when you do insert an item here, update an item over there. Talk about it for referential integrity. Or what if you change the last name in an employee table because someone gets married? Well, what if we change the last name there? Well, we need to also update it in a payroll table. So I can have a trigger that fires off. When you do an update on this table, also update this table and this table. So that's how they'd be helpful in referential integrity. We're going to execute this. I didn't get my create trigger after insert. Oh, that creates it. All right. And we're going to test it, and I don't have a command to test it. So let's see. We're going to do an update. So where's our update statement up here? This guy right here. We'll change this guy to square feet, just so we know we've changed it. And we'll execute this guy here. I still didn't get update production unit measure. Should have gotten just a baby little command. Oh, I did an insert. Okay, we need to do an insert. That was an update. Let's do this. So we're going to change this trigger instead of after insert. I did this on purpose so you know what we could do. We're going to change this to update instead. And then we're going to go up, change this to square footage.
That's not how you spell that.
Footage. Feet footage.
Feet-footage is cool,
Feet-footage.
but I don't think that's what you
Square
meant.
footage. Now we'll do one more update on this baby right here. Execute. What does it like? Is that name equals square footage? Where? Near F2. Did I not grab that last quote? Maybe I didn't. Let me see. I bet. Yeah, probably didn't. Well, I still need to get my trigger though. Oh, the trigger was already created on. Oh, okay. So you know what went wrong there is I had a trigger created for insert. That's already on the table. All I did is try to change this. I created another trigger for update, which probably failed because there's already one out there. Should have gotten an error on that. So all this would have done is down here instead of one row affected, it would have said unit measure is successfully added. It's not pretty, but it's a way to let you know. A better way for using triggers in the real world for referential integrity, I make an update on the last name column in the employee table. It needs to be updated in 3 other tables. That trigger fires and it updates it in accounts payable, and everywhere else that last name needs to be updated. All right, cool module on select statements and working with select statements and all the cool things for slicing and dicing the content. We went through all that with you. We talked about the different arguments, the between, the not. We saw all of these in action except for join. Just want to introduce those to you. And then we talked about DML commands, insert, bulk insert, update, delete. We saw all these in action. We looked a little bit at the clustered index and the non-clustered index, nothing to be too concerned about in the unique index. And then we talked about the use of triggers and how triggers can be used for enforcing referential integrity. If I make a change in one table, it can go out and update changes in another table. In our next section, we are going to talk about the fundamentals of database management, more of a, if you're a DBA, we're going to talk about securing objects, and we're also going to talk about backing up and restoring content, because that's one of the big tasks that you'll perform as a database administrator.